Hello, today we're going to look at the types of chemical reactions and we're going to look at examples. That is, this is a training lesson that will allow us to practice once again the arrangement of coefficients and indicating the types of chemical reactions. To simplify this work a little bit, I have included here as examples of schemes, how we will denote each type of reactions. With the letter S, we will denote a coupling reaction. With the letter D, it will be decomposition, it will be simple substitution, it will be double substitution, and combustion. But to begin with, in each of the equations, we will check the necessary additive coefficients, unnecessary ones, and indicate the type of reaction accordingly. So, let's start with the first example. As we can see, this is the reaction in the interaction between CO and oxygen. Here, in order to equalize, we will use the technique we talked about in the previous lessons. On the left side, we have oxygen on the odd side, and on the right side, we have oxygen on the even side. The rule works. Where it's odd, make it even. Hence, here we put a factor of 2, then carbon became 2, here 1, and to CO we put 2, and by oxygen check. Oxygen on the left is 4 and on the right is 4. So what type of reaction is this? As we can see, two substances have made one compound. It's a coupling reaction. Next, the second reaction. Here we first equate. So we have potassium on the left and on the right one each. OH group is 1 and here we have 3. Therefore, we will put the coefficient of 3 in front of potassium OH. Now the number of potassium has changed, hence we will put the coefficient of 3 to potassium and chlorine as well. Next, iron on the left side is 1 and on the right side is 1. Chlorine on the left side is 3 and on the right side is 3. So our equation is equated. What type of reaction is this? It is a double substitution reaction, hence we must state it this way. Furthermore, it will be a precipitation reaction because ferrum OH3 is an insoluble substance. Moving on to the next one. Silver nitrate has produced silver, NO2, and oxygen. Let's start equating. We start with the one whose index is greater. Oxygen on the left side is 3 odd and on the right side is 4 even. So we started with oxygen. I would like you to notice this point here again. Now where it's odd and odd here, we'll put a factor of 2. Now next, silver on the left side we have 2, on the right side we have 1. In front of the silver formula we put a factor of 2. Nitrogen on the left side is 2, on the right side is 1. In front of the NO2 formula we put a factor of 2 and check the oxygen. Here it's 6, here it's 4, 2 times 2, 4 and 2 more, you get 6. What type of reaction is this? One complex substance made several substances. It's a decomposition reaction. Here's the next interaction. Aluminum reacts with oxygen. You get aluminum 2 times 3. And this is where the least common multiple works. We start with oxygen. On the left side it's 2, on the right side it's 3. The least common multiple is 6. 6 divided by 2. Here we put 3. 6 divided by 3. In front of the formula, we put aluminum 2 into 3. The quotient is 2. The aluminum on the left side is 1. On the right side is a 4 multiple of 4. 4 divided by 1. 4 divided by 2. The 2 is preserved. So the equation is equated. So what type of reaction is this? Well, it's a reaction that's a compound, but it's also a reaction with oxygen. We could say it's also a combustion reaction. By the way, the first reaction, I'll come back to it, is also another additional combustion reaction. Let's move on to the next one. Potassium chlor3. We get potassium chlorine and oxygen. We start with oxygen. Its index is larger. On the left side, it's 3. On the right side, it's 2. The multiple for oxygen here works 6. 6 divided by 3. In front of the potassium chloro. 3 formula, put a 2. Here 6 divided by 2. In front of the oxygen formula, put a 3. Potassium on the left side is 2. Here 1, put 2 here. Chlorine on the left side is 2. On the right side is also 2. What type of reaction is this? It's one complex substance made into several substances. This is a decomposition reaction. Next example. C3H8, which is the organic substance propane, reacts with oxygen to produce CO2 and H2. We start to equalize. In this type of reaction, we start with carbon, hydrogen, and lastly oxygen. So there are 3 oxygen on the left side and 1 on the right side. So we put a factor of 3 in front of CO2. Hydrogen on the left side is 8, on the right side is 2. We put a factor of 4 in front of the formula for water. Oxygen on the left side is 2, on the right side it's 6. Give 4 more, 10. Then we put a factor of 5 in front of the oxygen formula. Our equation is equated. What type of interaction is this? It's a combustion reaction. The next reaction, H2 plus H2 yields NH3. So we're going to start equating. And here we can use a technique that sometimes works when we have indices that are placed accordingly. See, there's 2 nitrogen on the left-hand side, and there's 1 here. Then, to equalize, we can put 2 here. And the existing index 3 goes here as a coefficient. This is not always or very often the case where you can do this in terms of equalization. But it's not good for all examples, alas, only for some. So what type of reaction is this? It's a coupling reaction. Well, at the end we have an interaction between calcium chloride and sodium phosphate. You get H3 and chlorine and calcium 3 times 4 twice. Let's start equating. The calcium on the left side is 1, the calcium on the right side is 3. In front of the calcium chlorine 2 formula, we'll put a 3. Now the chlorine on the left side is now, we've got 6, and on the right side we've got 1. We'll put 6 here. Next we have the next interaction. Let's show sodium. Sodium on the left side is 3, and on the right side we see it's 6. So we need to put a factor of 2 here. Now further PO4 we have on the left side 2 and on the right side also 2. The equation is equated. What type of reaction we get? This reaction will be a double substitution reaction. But if we look among the examples I gave, it just so happens that there was no simple substitution reaction. Let us point out, so that this reaction will not be offended, that such a reaction is possible. For example, if we take zinc and hydrochloric acid, the reaction would produce zinc chlorine, 2 and hydrogen gas. Let's equalize zinc 1 at a time. Chlorine here is 1 and here is 2. Give chlorine 2, hydrogen 2, and on the right side is 2. And this reaction we have just a simple substitution. And accordingly, then you can see all types of reactions. We have seen in the simulator how they occur, these reactions, how we identify them by type. But besides that, look, the value of this lesson is also that we simultaneously repeated the ways of equating. That, for example, in the third example, the odd-even rule works. In examples, for example, in the fourth, and for example, in the fifth example, the least multiple works. And there are reactions that can be equated in such an unusual way. But I will clarify at once. Such reactions are not all possible to equate in such a way. In general, at first glance, not difficult way of equating. And also in combustion reactions, there is a special sequence of arrangement when we go from left to right, strictly in the order of carbon first, hydrogen second, oxygen third. So I hope the examples are clear and you can do such examples yourself without mistakes. That's all for today. Goodbye.